Okay, so example 4 on page 124. It reads, I'll just show it on here in case people are interested. It says, you got a traffic light weighs 122 newtons, hangs from a cable tied to 2 other cables fastened to a support, as shown in the figure right here. They give you the angles, 37 to 53 degrees with the horizontal. The upper cables are not as strong as the vertical cable and will break if the tension in them exceeds 100 newtons. Will the traffic light remain hanging in the situation, or will one of the cables break? This is a very, very practical problem. Okay, there is a field of engineering called civil engineering, and you will, as a civil engineer, need to make decisions about how to hang traffic lights. And if you use a cable that's not strong enough, you're going to kill somebody, or it'll break and it will be very expensive to fix. But if you use cables that are too strong, a lot stronger than you need, what's that going to mean? You're going to waste a lot of money. And your supervisor is not going to be happy with your work. So what you want to do is solve the problem at the least cost. Okay, that's what an engineer does. Solve problems at the lowest possible cost. All right, so I'm going to do step 1 of the procedure. Step 1 says do given, find, and solve with a picture. So here's like our solid surface. We've got a light like this. Here's one of the cables right here. This is 53 degrees right here. Here's another cable. This is 37 degrees. And again, it's not really all that close, but it's good enough. And then here's another cable. And then this was called T1 right here. And this is T2. And this is T3. Now these are tension forces. And then we got this traffic light, hung from here. And it's given that this has a weight of 122 newtons. So I'm just going to say that the force of gravity is 122 newtons. And what we want to know is, really what we want to find is T1, T2, and T3. And so we want to know, are any of these over 100 newtons? Because if they're over 100 newtons, one of them will break. Okay, so we just want to know what are the tensions in that cable. And then we can decide what kind of cable to buy. Okay, now let's solve it. All right, now I've done step 1 of the procedure. Step 2, draw the free body diagram. Now there's a couple of free body diagrams you can draw here. One of them is this object right here. We're going to isolate that object. And this is so easy and yet so powerful. So I'm just going to draw the traffic light. And what are the forces acting on it? Well, here's 122 newtons. That's the weight. That's Earth pulling it down. And then we've got T3, the tension force pulling it up. Now, what do we know is true about, that's step 2. Now, step 3 for this object is to identify an X and Y axis. So we're just going to do this for both of them, X and Y. But T3 and the weight are in the Y direction, so I don't need to break them into their components. Step 4, sum the forces using Newton's second law. Now, do I need to sum forces in the X direction? No. Do I need to sum forces in the Z direction? No. So let's just stick to the Y direction because that's the only direction that has force in it. I want you to write this every time. Whoops, I don't really need that. I underline it. That means, hey, I'm going to do all the Y direction stuff under here. And I'd say, okay, I got T3. Now, T3 is in the positive y direction. This is in the negative y direction, so I could add a negative force, or I could just subtract. Okay? So minus 122 newtons equals, now what is m times a in this problem? Well, what is my acceleration in this problem? I hope it's 0. That's your goal. So, in other words, T3 equals 122 newtons. Now, this was very, very easy. And you could say, why do I need to go through all that? Look, it's obvious that T3 has to be equal to 122 newtons. That's true. But I want you to learn to use this procedure. And you use it on really simple problems right now. Later on, when you become highly skilled at this, you can just go ahead and say, oh, okay, the acceleration is 0, so this is equal to that. But for right now, I want you to be very thorough, because we're really trying to learn the procedure here. Now, this free body diagram does not include T1 and T2. So what am I going to draw a free body diagram of next? Right. I'm going to draw a free body diagram of the knot. Now, the knot doesn't have very much mass, does it? But it doesn't matter. It's not being accelerated. Acceleration is 0, so the mass goes away. So you can just draw a free body diagram of that. And that's a good thing, because here the forces are concurrent. They're all acting on that point. So here's T2, and here's T1, and here's T3. But I know what T3 is, right? It's 122 newtons. So I drew the free body diagram. Now I'm just going to keep the same x, y coordinate system. But now I have to break up the forces into their x and y components. So here's the x component and the y component, the x component and the y component. Okay, now you really ought to label them, but I'm running out of time here, so I'm going to go fast. Now I'm going to sum the forces in the x direction. This is step 3, step 4. Sum the forces in the x direction equals ma in the x direction, which is 0 in this problem. So this is 0. So what have I got? I've got T2 in the x minus T1 in the x equals 0. So what does that tell me? T2 in the x is equal to T1 in the x. But T2 in the x, what is that? Well, this is 53 degrees here. So this is T2 times the cosine of 53 degrees is equal to T1, and this is 37 degrees, times the cosine of 37 degrees. So what this does is that this allows me to express T2 in terms of T1. T2 will equal T1 times the cosine of 37 degrees divided by the cosine of 53 degrees. Okay? But that doesn't solve my problem. I've got 2 unknowns, so I need 2 equations. So let us sum the forces now in the y direction equals, in this case, 0. ma, but again, acceleration is 0. So I've got T1 in the y. Now that's in the positive y direction, plus T2 in the y direction. It's positive as well. They're both up. Minus T3, which is 122 newtons, equals 0. So this is T1 sine 37 degrees plus T2 sine of 53 degrees. Am I still on screen? Yeah. Equals 122 newtons. Now, I am still, well, I'm running out of time here because the bell's going to ring, but here's what you do. you've got two equations and two unknowns. I'm going to leave the algebra one to you. You take this for T2, you plug it in there. Now you factor out the T1 and you got this big messy stuff thing. You divide that into 122 newtons and you've got T1. Then you plug that value for T1 in here, you've got your value for T2. So the step 5, we've now done step 4. Step 4 is to write the equations in the x and y direction. We can now do step 5, which is just algebra 1. It really rarely gets harder than algebra 1. You just solve for the unknown. Okay? And the answer turns out to be, I think T1 turns out to be 73.4 newtons, and T2 turns out to be 97.4 newtons, but that's in your book. So check that. But this is how, the main thing is, this is how you set up the problem using the procedure. That is all.